Mars has two permanent polar ice caps. During a pole's winter, it lies in continuous darkness, chilling the surface and causing the deposition of 25 to 30% of the atmosphere into slabs of CO2 ice. Dry ice. When the poles are again exposed to sunlight, the frozen CO2 sublimes. These seasonal actions transport large amounts of dust and water vapor, giving rise to Earth-like frost and large cirrus clouds. Clouds of water ice were photographed by the Opportunity rover in 2004. The caps at both poles consist primarily of water ice. Frozen carbon dioxide accumulates as a comparatively thin layer about 1 meter thick on the north cap in the northern winter only, whereas the south cap has a permanent dry ice cover about 8 meters thick. This permanent dry ice cover at the South Pole is peppered by flat-floored, shallow, roughly circular pits, which repeat imaging shows are expanding in some places and retreating in others. The northern polar cap has a diameter of about 1,000 kilometers, 620 miles, and contains about 1.6 million cubic kilometers, 5.7 times 1,016 cubic feet, of ice, which, if spread evenly on the cap, would be 2 kilometers, 1.2 miles, thick. This compares to a volume of 2.85 million cubic kilometers, 1.01 times 1,017 cubic feet, for the Greenland ice sheet. The southern polar cap has a diameter of 350 kilometers, 220 miles, and a thickness of 3 kilometers, 1.9 miles. The total volume of ice in the south polar cap plus the adjacent layered deposits has been estimated at 1.6 million cubic km. Both polar caps show spiral troughs, which recent analysis of Sherrod ice-penetrating radar has shown are a result of katabatic winds that spiral due to the Coriolis effect. The seasonal frosting of areas near the southern ice cap results in the formation of transparent, 1 meter thick slabs of dry ice above the ground. With the arrival of spring, sunlight warms the subsurface and pressure from subliming CO2 builds up under a slab, elevating and ultimately rupturing it. This leads to geyser-like eruptions of CO2 gas mixed with dark basaltic sand or dust. This process is rapid, observed happening in the space of a few days, weeks or months, a rate of change rather unusual in geology, especially for Mars. The gas rushing underneath a slab to the site of a geyser carves a spiderweb-like pattern of radial channels under the ice, the process being the inverted equivalent of an erosion network formed by water draining through a single plug hole.